Okay, let's take a look at examples 5, 6, and 7. All right, so for this one, as you look at it, right, you might think both sides look equally complicated, and you probably would not have an argument for me here, but I'm going to use the left-hand side, okay, because there's some radicals, and there's just more things that we can do when given a radical and a fraction, okay? The absolute value, I'm going to leave that alone. So one of the strategies that you learned, right, is you can multiply an expression with a fraction by its conjugate in the denominator, but you can also multiply the conjugate of the numerator. So for this particular problem, I'm going to multiply by the conjugate of the denominator. And the conjugate is just simply the opposite sign of this. 1 plus cosine x, the opposite is 1 minus cosine x. So do that to top and bottom. And then as you simplify over here, well, it looks like I'm going to be running out of space. Let me just erase over here all these extra examples I have down here. I'm clearly not going to have enough space. Okay, so as I multiply by the conjugate, you can see what's going to happen, or hopefully you can see what's going to happen. In the numerator, right, you're going to have 1 minus cosine of x. Because there's 2 of it, it's quantity squared, right? And then in the denominator, I have the pattern of a plus b times a minus b, right? And if you forgot what a plus b times a minus b, your algebra teacher is not going to be too happy. It's a squared minus b squared, okay? That's your sum and difference pattern. So that gives you 1 minus cosine squared x. All right, so as you can see, right, I could split up the radical if I don't have to. I'm just going to do that. You can see that you can take the perfect square of you could take the square root of a perfect square, right? And then the square root of 1 minus cosine squared x, right? That's just sine squared x. And you're done, right? The square root of a perfect square is just the radicand itself, and then we'll just stick some absolute values over here because we can't assume that all values are positive. Okay, so we'll be done with that problem. And then let me write out the second to last example, example 6 again. I believe it was this one right here, 1 minus tangent squared x over 1 plus cotangent of x minus pi over 2. And then that equals cosine of x plus sine x all over cosine x. Okay, so as you stare at this problem, right, you'll notice that this should trigger something, right? It's like, oh, wasn't there like some kind of cofunction identity? And the answer is yes, okay, but there is an issue. And what do I mean by that? Note, the theorem itself was not x minus pi over 2, right? It was pi over 2 minus, in this case, we'll just call it x, right? I believe in the notes I gave you theta, but sure, let's call it x. This is the actual theorem. Cotangent of pi over 2 minus x is equal to tangent x, right? Now, these two expressions are different. So let's see how we're going to go about manipulating that, okay? So let me see if I can rewrite this expression right here as cotangent of negative pi over 2 plus x. Okay, so let's start with that. All right, just rewriting the terms. And then within that argument, I'm going to do a little factoring, right? Factor out a negative 1. That's pi over 2 minus x, all right? So now you can kind of take a look, right? This almost looks like this, right? This almost looks like that, almost. Okay, so just for another visualization hint, if I just call this pi over 2 minus x, call it theta, right? This will be cotangent of negative theta. Now, cotangent of negative theta, right, is another one of your identities. That's just simply the negative of cotangent of theta, okay? And what was theta again? Well, theta was this. Let's substitute this. That's pi over 2 minus x, right? And what is this? Well, that is just tangent x, okay? So I went about a long, lengthy process to prove to you that cotangent of x minus pi over 2, right, just equals negative tan x. All right, so it's not tangent x, it's negative tan x. All right, so let us go back to the original problem. We already know that that's going to be negative tan x. I see a tangent squared x in the numerator, so I'm going to rewrite that as 1 minus sine squared x over cosine squared x all over what we have over here was a 1 plus tan x, right? Or 1 minus tan x. 1 minus tangent x. Now, tangent x, right, is just sine x over cosine x. Okay, so just, convince yourself that what I've done so far is called this sine squared x over cosine squared x. And then cotangent of x minus pi over 2, right? I went through that process to prove to you that it's negative tan x. And negative tan x is just negative sine x cosine x. Okay, so, saving the second the hardest problem for near the end. Now, hopefully you can see, right, that I have a complex fraction. And the way we clear our complex fraction, right, is multiply top and bottom by the LCD of the denominator. So the LCD of cosine squared x and cosine x is just simply cosine squared x. Okay, so very, very lengthy problem. Let's finish this off here. Let's distribute in the numerator. I get cosine squared x minus sine squared x. In the denominator, I get cosine squared x. One of these cosine x is going to cancel out, right? Just one of them. So that's a minus cosine x sine x. And then where do we go from here? Well, remember the end is that we have a cosine x plus sine x, right? Cosine x plus sine x over cosine x. So kind of just keep track of what you want your finished product look like, right? By looking at the other side. Okay, so in my numerator, I can factor difference of two squares. That's cosine x plus sine x times cosine x minus sine x. In my denominator, I can factor out cosine x as a GCF. That will give me cosine x minus sine x. And now you can see, right, that I have some common factors that I can cancel out, and I am done. Okay, so that was, not an easy problem, but the algebra skills needed here, right, of manipulating the cotangent pi over 2 minus x by rewriting it and factoring out the negative, and then essentially show you that this guy right here, x minus pi over 2, cotangent of x minus pi over 2 equals negative tan x. That was, I guess a little bit of extra work there, okay? All right, so the last example, why don't you, maybe pause the video and then just try this on your own, okay? I took this problem out of an not old math 3 textbook, but basically your math 3 textbook from the Big Ideas, okay? So there was definitely trig in that textbook, and that's where I got the problem. So why don't you try pausing the video and see if you could try attempt this problem on your own. And it should be obvious, right, that the left-hand side is the more complicated side. And my hint for you is just try to convert everything to sine and cosine, okay? By the way, this is a secant of negative theta. That kind of looks a little bit unclear, okay? All right, so hopefully you, try your best and then see where you got stuck. So my hint, right, was the left-hand side is the more complicated side. So what I'm going to do first, right, is simply rewrite secant of negative theta. In fact, I'm just going to show the work here on the side. Okay, secant of negative theta, right, is 1 over cosine of negative theta. And 1 over cosine negative theta, well, that's just 1 over cosine theta. Okay, so if you show the work on the side, that's okay. But always show your work on a quiz or test so you don't lose points. And then if I convert the tangent squared theta into sine and cosine, right, that's sine squared theta over cosine squared theta. Okay, so now as I look at my problem, right, I can see that there is a complex fraction, right, and so that seems to be the theme of the last two problems, right. You definitely need to simplify your complex fraction by multiplying by the LCD of the denominators. So the LCD of cosine theta, cosine squared theta, is simply cosine squared theta. Okay, so I'm going to distribute. All right, so over here, distribute the numerator. You get 2 cosine cubed theta. Cosine squared times 1 over cosine. One of the cosines cancel out, right? You have a cosine of theta. Distribute the denominator. You get cosine squared theta when you multiply by 1. And then over here, the cosine squared thetas cancel out, right? When you distribute to the second term, you're just left with sine squared theta. Okay, so at the end of the day, right, everything needs to cancel out to cosine of theta. And I have a bunch of sine, well, I have the sine squared term, sine squared theta, that is kind of annoying. So what I'm going to do right now is just do a substitution. And so let's do that here first. Cosine squared theta minus parentheses 1 minus cosine squared theta. Okay, so make sure you put the parentheses. And it looks like I'm going to have to do a little bit of factoring. So in advance, I'm just going to factor a GCF. I factor a cosine theta over here. I'm left with a 2 cosine theta minus 1. Okay, so it looks like we're getting somewhere. Let's see if we can combine some like terms. If I distribute here, I get a minus 1, right? And then if I distribute here, that's a plus cosine squared. Well, cosine squared plus cosine squared, that's 2 cosine squared theta. 2 cosine squared theta minus 1. And it looks like I have a little bit of typo. All right, so going back to what I had here earlier, right? This, when I factor out this cosine theta, this should be a cosine squared, okay? Okay, so as I put this together, you can kind of see where this is going, right? Or hopefully you can kind of see where this is going. Notice these guys are common factors, and they cancel, okay? And you're done. Okay, so in general, like I said, right, you're going to have to try some things. Your algebra skills definitely need to be sharp. If they're not, right, this is a chance for you to practice. And then, of course, you have to know all your trig identities and be able to substitute at the, as necessary, right? And again, you're not going to get really good at this overnight, right? You have to practice it. So again, we'll spend at least 2 days, if not maybe 3 days on this topic.